Alright, here's lesson 3.5. I can solve two-step equations and check my solutions to make sure my answer is reasonable. Alright, so we've just finished doing one-step equations, and a one-step equation means we're doing one step to solve it, or one thing happened in the problem, one thing needs to be undone. Let's do a few to remember how we did that. We circled our variable, we said it's added to 7, so we're going to do the inverse, which is subtracting 7, canceled out on the right side. On the left side I get -1. We can check that by saying 7 plus -1 is equal to 6. Okay, let's check the next one. So my variable is touching the number. When they're touching, we know that when a letter and a number touch, it means they're being multiplied. So this is 7 times m. To get rid of times 7, we're going to divide by 7. 35 divided by 7 is 5. These cancel out, so I have m left over. Is 7 times 5 35? It is, so we're right. Now we're going to do some two-step equations where there's two operations happening in the problem. I see my variable, here is x, and it looks like x is being multiplied times 3 and x is being subtracted with 2. So my two operations is times 3 and minus 2. So we're going to get rid of two operations. In order to do that, we need to know what order we need to get rid of them in. So think about backwards order of operations. We're always going to start at the last thing we did to the problem to get rid of it. So the first thing you're going to get rid of is addition or subtraction. The second thing you're going to get rid of is multiplication or division. And we're still using inverse operations just like we did the last 2 days. So we're going to do the same thing we've been doing. Only we're going to do that twice. Okay, what two operations are in this equation? Well, I see that I'm multiplying times 2 and I'm adding 5. Which one am I going to get rid of first? Adding 5. How do I get rid of it? Subtracting 5. Okay, second thing, which operation will I get rid of second? Multiplication times 2. How do I get rid of it? Divide by 2. Alright, so let's look at this problem. I'm going to do these two things. First, I'm going to subtract 5 from both sides. I get 6 on this side. This side cancels out, so I have 2x left. Okay, now I'm going to go on to the second part. Well, if you look at just this part that's down below my line, you can see now I have a one-step equation that's simple to solve. So I'm just going to divide by 2, and I ran out of room, but I get 3 is equal to x. And I can plug that in and say is 2 times 3 plus 5 equal to 11? It is equal to 11. Let's do another one. So here, what two operations do I have? I have subtracting 6. That's the one I'm going to undo first. Remember, we always undo addition or subtraction first. I also like to think of it as we're undoing the thing that's a little bit further away from the variable first. How do I undo minus 6? Add 6. Okay. Secondly, I would undo my multiplying times 3 by dividing by 3. So here we go. I'm going to add 6 to both sides. I get 12 on the right. On the left, I have 3y. Next, I'm going to divide by 3 to both sides, and I have y is equal to 4. Check it. 3 times 4 is 12. 12 minus 6 is 6, and that is correct. Let's do some more. These look a little bit different, and that's just because this is how you're going to get your problem. It's not going to have any help on the sides for you. So let's draw our train tracks. I am looking at this problem. I need to undo my addition or subtraction first. So I'm going to add 19 to both sides. On this side it cancels out. On the other side I have 35 is equal to 5x. I like to rewrite my problem. Now I'm going to undo my multiplication by dividing by 5 on both sides. So I have 7 is equal to x, because 5 divided by 5 is just 1. Alright, let's test it. 5 times 7 minus 19. 5 times 7 is 35. Minus 19 is 16. We did good. Alright, here's two examples on this page. So, we've got to undo our addition or subtraction first. So I'm going to add 6 to both sides. This side it cancels out, and I have 4h left over. This side I have 8. Next, I'm going to undo my multiplication by dividing by 4 on both sides. So I have h is equal to 2. Test it. 4 times 2 is 8. 8 minus 6 is 2. And I got it. Let's do this one. Alright, I'm going to undo my addition or subtraction. So I'm going to undo the minus or plus 5 by subtracting 5 on both sides. 3 W's left on the left-hand side. On the right-hand side, 15 is left. It's super helpful to do this step of rewriting your problem again. That way you can see, now what do I have left? Alright, so I'm going to divide by 3 on both sides. 3's cancel out, so W is left. And this side I have 5. In my head, I'm just checking. 3 times 5 is 15, plus 5 is 20. Alright, this one has some negatives, so it's a little bit different. I'm still going to get rid of my plus 3 first by subtracting 3. Now I have negative 28 is equal to negative 7y. Okay, and I'm going to do this again. Divide by negative 7, divide by negative 7. Y is equal to, remember, a negative divided by a negative is a positive answer. Check it. Negative 7 times 4 is negative 28. Plus 3, 27, 26, 25. Negative 25. Alright, I'd like you to pause the video now and try these 3 problems. Okay. Here are your solutions. S equals negative 4. R equals 12, X equals 9, and N equals 20. Let's do a word problem. Paul has $145 in his savings account. He earns $36 per week mowing lawns. If Paul saves all his money, how many weeks will it take him to have $433 saved? Well, it's telling us weeks is W, so that's giving us a clue that we are going to be using weeks as our variable. If I have $36 per week, per is one of those giveaway words that we're talking about multiplication typically, or division. So we're definitely going to be taking this $36 and multiplying it by the number of weeks. Because if I worked 1 week, I'd have $36. 2 weeks, I'd have double that. 3 weeks, triple that. So I start with $145. I add on my $36 per week, and I get $433 saved. Now this has some really big numbers in it, but we can do it. Alright, first thing we're going to do is we're going to get rid of our addition or subtraction. So I'm going to subtract 145 from both sides. Alright, slow down when you've got big numbers. We don't want to make any mistakes. So I'm going to borrow here. 13, 8, 12, 8 again, and 288 is equal to 36 times W. So how many weeks basically would it take me to earn $288, which is what I added to my original amount? So we're going to divide by 36, and divide by 36, and unfortunately this one I can't do in my head, so I'm going to go over off to the side and do some long division. Say, alright, I'm going to estimate 36 to be about 40, let's say. If it was 40, that would be 7 times that it would go into 200. Sorry, 7 times 288. Let's check. 7 times 6 is 42. 7 times 3 is 21, 22, 23, 24, 25. And it looks like we might be 1 short. Let's see. Yep, we're exactly 1 short. So instead of redoing my whole problem, we're just going to up this and say, okay, we could have done 1 more. So how many weeks was that? 288 divided by 36, it's 1 more than 7, which would be 8 weeks. Word problems should always have labels. Alright, one last word problem. A rental store uses this equation to charge people for trucks that have been turned in late. So if F stands for the amount of fined and H stands for the amount of hours, Mr. Doherty pays a $17 fine. How late did Mr. Doherty turn in the truck? Well, F stands for the fine, right? And they said his fine is $17. So we're going to put $17 where the F was. Make it equal to 5 plus 2H. And solve. Subtracting 5 from both sides. So I have 12 is equal to 2H. divide by 2, and I have 6. Mr. Doherty was 6 hours late. All right, you are done. Make sure you go and do your NICU check.